Determine the mass of a 2-meter rod whose density varies linearly from 3.2 kilograms per meter to 6.8 kilograms per meter. So I'm going to draw a picture of this rod. It's 2 meters. So we're going to call this endpoint 0 and this endpoint 2. And then I'm going to add the density that I know at each value. So it varies linearly from 3.2 at one end, and at the other end, the density is 6.8 kilograms per meter. And they said it varies linearly, so I could find the density at any point in between because I know that it's determined by a line between these 2 points. So the slope of that line would be 6.8 minus 3.2 over 2 minus 0, which is 1.8. So my density function, which you're typically given, but in this case they made us figure it out ourselves, would be 1.8x plus the y-intercept, which is the y value when x is 0, which is 3.2. Okay, so I've got a density function now. And like I said, you're usually given a density function, but we were able to figure it out from the description. So I want to know the mass of this rod. Mass is going to be density times length. But because the mass varies, I can't just do it all in one calculation. So I'm going to pick a random spot along the rod between 0 and 2, say it's a distance x meters in, and break that into a little tiny chunk, so small that the density is practically uniform on that small little piece. And I'm going to calculate the mass of that slice. The mass is going to be density times length. The density of that little slice is given by the function delta of x, 1.8x plus 3.2. And then the length of that little slice is delta x. So that's the mass of my slice. Then I have to add up a whole bunch of these little slices, each at a different x sub I location. So I'm going to take the sum from I equals 1 to n of 1.8xi plus 3.2 times delta x, and take the limit as n goes to infinity, and this will tell me my total mass of the rod. That is a Riemann sum. It translates to an integral, 1.8x plus 3.2. The delta x translates to a dx, and then my integral bounds are going to be 0 to 2. That's where I'm starting and where I'm finishing, adding up these little x values. So this is just a straightforward integral. This becomes 1.8x squared over 2, so 0.9x squared plus 3.2x, evaluated from 0 to 2, which comes out to 10 kilograms.